Oh, yep. So, hello everyone, and welcome back to my technology dive stream. Today, the topic that we are going to talk about is quite interesting. That is volunteer distributed computing, discovery from your own very own computer. Yeah, we're talking about that you can actually contribute to many things just by running a program on your computer. Yeah, first of all, the power of Legion computers. Distributed computing allows multiple computers over a network to solve the same computational problems by dividing a large task to several smaller tasks solved independently of each other. So, with the power of distributed computing, we can spread around lots of work towards many computers over a network, and by over a network, it can be around the world. So, for example, you can have a computer in, for example, Japan and a computer in the United Kingdom, for example. They can work on the same task. And then, computation for some scientific research can be divided up and distributed between multiple systems. So yeah, there are some problems that can be parallelized and divided into multiple computers and be made into distributed systems. And as I said before, it can be across the world here. And then yeah, with the power of many several distributed computing projects have sprung up, tackling various problems, and boy, they are really favorite here. There are a lot of variations in the project's purposes, from getting the next world record to helping scientists in the fight against COVID-19. Yes, there are several projects in the distributed computing space that focus on different things. Some of those are for fun, finding the next world record. And then there are some that are for more, I guess, more benevolent purposes, like helping scientists around the world to figure out what the heck is with COVID. Also, ya, Matt Malam, ya, halo Yuki. Oke. Ya, jadi kalau aku jelasin lagi dalam bahasa Indonesia, jadi dengan proyek-proyek distributed computing ini, ya banyak masalah yang bisa diselesaikan dengan membagi-bagi suatu kegiatan, jadi bisa dibagi-bagi ke berbagai komputer ke seluruh penjuru dunia, dan fungsinya itu macam-macam, dari cuma sebatas rekor dunia aja sampai bisa membantu para ilmuwan untuk menemukan bagaimana caranya melawan penyakit COVID-19 yang sekarang lagi melanda dunia. It's pretty cool to help fight against the pandemic the cool way. And then, yeah, after this I will be okay. Well, window capture did not go so well here. Okay. Reminder to myself, don't use window capture for presentations. It does not work well. For some reason, it just kind of got stuck there. So yeah. And then, yeah, I will talk about several projects here. Ada beberapa project distributed computing yang aku temuin dan aku udah coba jalanin sendiri, dan mereka itu ya banyak hal keren yang mereka lakuin. There are a lot of cool things that they are doing. Jadi kita langsung bahas aja. We are going to immediately discuss about those projects. The first one here is what is called the Great Internet Machine Prime Search. Ya, jadi ini fungsinya itu dia ya fungsinya itu mereka mereka itu mencari bilangan prima terbesar yang pernah ada. They are trying to find the largest prime number ever discovered, and their specific focus mereka itu bilangan primanya itu adalah bilangan prima Mersenne, or Mersenne primes. They're focusing on Mersenne primes, which are in the format of 2 to the power of x minus 1. Ya, jadi bilangan Mersenne prime itu adalah bilangan prima yang bentuknya itu bisa dijabarkan sebagai 2 pangkat x minus 1. Nah, sama ini menariknya itu, games ini, kalau kamu berhasil menemukan istilahnya bilangan prima terbesar selanjutnya, bisa dapat duit. If you're lucky to discover a new largest prime, there are monetary prizes that you can claim, which is quite cool. Well, although it might be that it feels more like a mathematical lottery here. Apa sih kemungkinan bisa dapat bilangan prima terbesar? Also, komputasi buat ngitung bilangan prima itu gak gampang. The computation to calculate whether a number is prime or not is really hard. I think the algorithm that they are using to test for primality itu algoritma yang mereka pakai buat mereka bisa cari bilangan prima itu, ngecek bilangan prima atau bukan, itu namanya Lucas-Lehner primality test. Let me immediately check that out here. Okay, let me switch to window capture here. Kita pindah ke window capture. It's a Wikipedia page, but it should be good enough for our purposes. So jadi I will not bore you with the details here. Jadi ini algoritma yang mereka pakai buat nyari bilangan prima. Buat ngecek itu bilangan prima atau enggak. This is a primality test algorithm to check whether a number is prime or not. And then okay, I will not bore you with the mathematical details. They are boring, but just so you know that this is the primary algorithm that the Great Internet Mersenne Prime Search, the project here, this is what they're using. The test is considered failable because it can probably test a large set of very large numbers for primality within an affordable amount of time. Jadi dia bisa cepat. So that's the Great Internet Mersenne Prime Search. The software that they use to... Okay, let me return back here. The software that they use to participate in the Great Internet Mersenne Prime Search is the software called Prime95. If you have been in the CPU overclocking space, you might be familiar of this tool as the software to test for the software to test CPU for stress levels, and to check whether your CPU is stable or not. Well, it is actually a client for the Great Internet Mersenne Prime Search, so that you can receive tasks and then your computer will do them while you're away. So a similarity of those programs, distributed computing program, is that they usually run when you're away from your computer, and they usually recommend that you run this program like 24/7, and it will usually automatically detect whether you are away from your computer, and then immediately use that time to calculate crunch numbers or other things that they want you to do with your computer. So jadi itu adalah GIMS, the Great Internet Mersenne Prime Search. And then the next project that I am going to highlight here, still mathematics related, masih berhubungan dengan matematika, Distributednet. Jadi ini awalnya ini tujuannya mau nge-crack. Distributednet is originally founded to crack. Yeah, they're tackling the RSA Secret Key challenge. I will probably search them again here. I will switch. I will switch to. I will switch to the page here that explains stuff. Okay, where is... Okay, let me actually try to track the, secret key lab challenges here. Okay, yeah. Well, the downloads are quite slow for some reason. And I don't think anyone's okay, yeah, I will just explain a little bit on what is the RSA Secret Key challenge. So they basically give a bunch of encrypted text and ask you to guess what the key is and find the secret message. And then the Distributednet project was originally founded to help tackle this challenge because, the only true way to actually getting the message in the secret key challenge is to brute force it. Jadi satu-satunya cara biar bisa nemuin itu, what is RC572 for? I will explain that later. Yeah. I'm explaining the RSA Secret Key challenge, which should answer what is actually RC572. Okay, the page has actually loaded, yeah, so I will switch to that. Thank God, it was somewhat slow. Nah, jadi RSA Secret Key Challenge ini mereka disuruh nge-crack. Jadi, what does those numbers mean? Yeah, RC5 is the algorithm. Jadi, RC5 ini adalah algoritmanya, dan angka-angka di belakang ini itu adalah angka yang bermaksud. Jadi ini kayak panjang key dari message yang dienkripsi tadi. This number down here is the key length of the message being encrypted. So if you can crack that key, you can get those prizes. Dan ya, itu awalnya projectnya ditemuin buat itu. Kemudian, ya, actually I think they did pretty well. Let me search here. Jadi dia ada halaman history-nya sendiri di sini. Ya, mereka awalnya nyelesain RC5 32 12 7. This thing. Terus mereka nyari ini nomor challenge-nya ternyata. So 32 19 20 3212.7 ini adalah 56 bit. 56 bit, jadi mereka mulai cari dan ini mereka ketemu sekitar ya hampir setahunan. Terus mereka lanjut ke RC5 64 bit distinct. Yang 64 bit itu ya mereka ketemu 5 tahun lebih. Jadi di brute force. Terus ya karena udah kelar, oke, let's go back down to 2002. Nah, mereka akhirnya mulai nyari yang 72 bit. So yeah, the 72 is the key length. Jadi maksudnya RC5 itu adalah algoritmanya, 72 itu adalah panjang key-nya, panjang kuncinya. And yeah, they have started since 2002. Dari 2002 loh. Dari 2002, masih belum kelar-kelar. Look at this. The key space is like, wow, 1% in 2 years. Jadi key space itu nyarinya, wow, 2 tahun cuma 1%, guys. 2 per tahun cuma 1%. 1% in 2 years. That is a heck of a long time. Like crazily long time. Ya, dan as you can see here, the website is quite a bit old-fashioned here. Oh, it brings me back the memories. Ya, jadi itu adalah Distributednet. Terus, project selanjutnya, this is one of the more famous one. Lol. Yeah, that is a heck of long time. Yeah, and they're not finishing up anytime soon. Their last progress. Look at here, the last progress. No, not this one. But this, okay. 7% complete. September 10, 2020. 7%. And it has started since 2002, everyone. 2002. 19 years. That's a long time. Yeah, because cracking those requires quite the amount of computing power. Quite an understatement there. 19 years and it's still 7%. The day they finally discovered it will be the day I rejoice. And also, they also have a side project that is finding the optimal 28 golem rulers currently, and the progress is around, yeah, they have verified 370 million stubs. Compared to this RC5 project, which I understand is about a cryptographic algorithm, OGR is more obscure. I don't have an idea of what are those at all, so I will not be covering them in depth. And then the next project is one of the more famous ones, one of the more famous distributed computing projects, and we are shifting away from mathematics to biology. So let's go ahead and talk about this project, Folding at Home. And it's okay, I forgot to switch there. Folding at Home, this is quite the project. It's really large, and it has been its growth has been helped partially by the COVID-19 pandemic, because what it does is it basically calculates protein folding. It simulates the protein folding and movements, among other things. And because protein research is important in virus research, Folding at Home had a surge of popularity due to the pandemic. And Folding at Home has also helped scientists in designing treatments for COVID-19, and for specifically for the virus SARS-CoV-2. So let me go back to the website to the browser shortly, and I will demonstrate the homepage of Folding at Home. Together we are powerful. Together we have created the most powerful supercomputer on the planet and are using it to help understand SARS-CoV-2 or COVID-19 and to develop new therapies. We need your help pushing toward a potent, patent-free drug. Use your PC to help fight COVID-19. Yes. So yeah, what Folding at Home does, they simulate the protein structures of the protein, like the COVID-19 protein, and then they were able to find structures that can be targeted by drugs. And Folding at Home ambassadors, you can see that there are several pretty powerful names in there. Okay, just look at the first three lines here. Microsoft, Satya Nadella, Lisa Su, AMD, and Jensen Huang, NVIDIA. That's pretty powerful. First opener. Okay, let's play the... there's a video here. I think I will not be playing it on stream. But there's a video. And so you can check them out. Oh, Intel too. Intel. And then here you can see lots of corporate ambassadors, but also a lot of university people. And this one is kind of more interesting. You read this like PCMR. Yes, PC Master Race. This is kind of interesting. And they have downloads for Windows, Mac OS, and Linux. I will talk about those later when I actually get to talk about the software themselves. Let me check a bit about the statistics. Okay. Okay, so you can I really can't find data. I can't find the data on how much computing stuff is here. Oh, it's here. So the operating system statistics here. Wait. Okay, right. So the amount of teraflops that they have returned is massive. Around 80,000 teraflops. 80 petaflops. That is very impressive. And then it's kind of a competition too, because if you think about it, joining on those distributed computing projects is a lot similar to mining cryptocurrency, for example, because they also have to work to get the result. However, what you do with distributed computing is that you contribute to a lot of useful stuff. Like the Folding at Home project here, as I said before, helps tremendously in combating diseases. I think there are diseases, among other things. Okay, let me check here. The diseases they are researching, other than COVID, are things like Alzheimer, cancer, cancer, and then they have Alzheimer's, and then lots of infectious viruses here. And so if you contribute to Folding at Home, you can take part in helping for treatments towards those diseases. So yeah, you can do science at home too, like this. And then I will return to the PowerPoint and let's talk about the next project. It's not a project in the sense of individual projects like games and folding at home, but it's a infrastructure. Yeah, this is actually the original title for this stream. I was originally only trying to cover Boing, but it ended up expanding a bit into the other distributed systems. Well, because I remember them again. But yeah, the original inspiration is the Boing. Boing is the vertically open infrastructure for network computing. It is not specifically a project like others, but it's more like a system infrastructure for other distributed computing projects. And so they have like one client for them all. It was originally created to support the SETI at Home project. So the SETI at Home project is basically you try to find signs of extraterrestrial beings from transmissions. Yeah, kind of. Looking back at it, it's kind of, yeah. And the project itself is currently suspended indefinitely. There's a bit of a sad news here because, like, I think the primary source for transmissions is the Arecibo telescope, and that telescope collapsed back in 2020. Ouch. I accidentally opened my Explorer instead of clicking on the browser. Thankfully, nothing weird. Yeah, the Arecibo telescope is down, and yeah, but you know, because they open source the component here, that means that other projects can use Boing as their basis for their own distributed computing projects, and that is what I am going to talk about next. We are still at biology territory, and yeah, it also focuses on protein research. I don't see anything up yet, thank God. Yeah. So like Rosetta at home, like Folding at home, they are also involved in protein research, but it kind of works differently than Folding at home because I think Folding at home simulates the protein folding process itself. Rosetta at home kind of tackles it from the other way around. They try to predict protein structures and design, and they are also helpful in the fight against COVID-19. They operate complementarily, not like competitively, and work for one can be improved with the other, and they use the Boing platform. Let us go to the browser again to explore the Rosetta at Home project. You don't have to be a scientist to do science. By simply running a free program, you can help research in medicine, clean energy, and material science. Ya, jadi ini project page mereka. This is their project page, and what you can do is you can see, you can read about what are those. Yeah, you can read them on your own here. And yeah, Although Rosetta at Home was not directly used for the work described in the publication, Rosetta at Home was used for designing relevant scaffolds. Ya, jadi ya Rosetta at Home juga membantu untuk riset COVID-19 juga. So yeah, their news section is kind of outdated, but I think you can visit the community here to check out about the news. But yeah. Thank you. We'd like to thank you everyone who has contributed and continues to contribute to this project, and would like to remind everyone that there may be periods of downtime while we are preparing for future large-scale batches of jobs and analyzing results. We greatly appreciate your contributions, which are vitally important to our ongoing research. Yeah, there are still not much update here, but yeah, pretty cool. And yeah, you can see from here, like you can see the account. Oh, I do have an account and I do have some credits there. I will talk about this later. Yeah, I do have an account in Rosetta at Home. I will explain about them later in the stream. But yeah, Rosetta at Home also kind of dabbles in the same biology topic as Folding at Home, but they tackle the problem from different perspectives. And the next, we stray out of biology and we dive to astrophysics. There's a typo there. Never mind that one. Astrophysics. So Einstein at Home. This project is quite interesting. What they do is they are searching for signals from pulsars, that is rotating neutron stars, with data sourced from instruments such as LIGO, the Laser Interferometer Gravitational Wave Observatory. There are also other instruments that they use here to search for pulsars, and it's quite interesting to see too. Let us switch to the browser tab again, and let's explore Einstein at Home. Yeah, I kind of forgot to switch the page there. Okay, yeah. Okay, Einstein at Home. So they use your computer idle time to search for weak astrophysical signals from spinning neutron stars. Pulsars using data from like LIGO, the Arecibo Radio Telescope, which has collapsed, and the Fermi Gamma Ray satellite. So gravitational wave, radio, and gamma ray. User of the day, owner. So yeah, as you can see here, there is a discovery as recent as 1 month ago, whose computers have found 14 new pulsars. So yes, by contributing to this project, you are able to find new stars, basically. And also help progress the advance of science from a different perspective. Last time we were talking about biology, we're talking about astrophysics now. Let's switch back to the presentation here. And then let's talk about another astrophysics project, the Milky Way at Home. Okay, not yet. So the Milky Way at Home, instead of searching for pulsars like Einstein at Home did, what Milky Way at Home does is they are trying to create a high accuracy 3D model, a high fidelity 3D model of our own galaxy, the galaxy that we live in right now, using data sourced from the Sloan Digital Sky Survey. if you have seen like the quote pictures of of our galaxy, the most of the popular culture ones are not actually the Milky Way itself. The pictures that we see about our galaxy on the on popular culture, the images that we often see are not actually the Milky Way. That's the Andromeda galaxy, the next door galaxy. But with this, we are trying to create a model of the galaxy, of our actual own galaxy, using the sky survey. And it also uses the Boing platform. So let's go to the nice one there. Let's go to the project website here. Milky Way at Home uses the Boing platform to harness volunteer computing resources, creating a highly accurate three-dimensional model of the Milky Way galaxy using data gathered by the Sloan Digital Sky Survey. This project enables research in both astroinformatics and computer science. Yeah, so they also have news as recent as 5 days ago. Okay, there are recent news, and what they do is also really cool. Although the picture is, yeah, kind of like this. And after that, after we discuss about those, wow, science, wow, mathematics, we are continuing with something that is still science, but it's not it's not always biology and astrophysics, something like that. Let's talk about the World Community Grid. Yeah, it like involves in, there's biology right there, but there's also something really interesting. Yeah, first of all, it's run by the IBM, the IBM that makes huge mainframes. Yes, the same IBM runs this distributed computing project. They also involve themselves in COVID-19 research. Pretty cool. And also they also search for cancer molecular markers. But really interesting project here is they are trying to improve rainfall modeling for Africa. Well, I suddenly just remembered that particular Toto song while looking at that particular topic. But yeah, I cannot play the song in the stream unless I want myself to be hit by content ID. So yeah, they are multi-purpose, and there are several projects that you can participate. Okay, let's switch to the World Community Grid website. So yeah, those are the big threes: open pandemics for COVID-19, the rainfall modeling, and cancer molecular markers. And just like any other distributed projects, you can download a client to help those distributed computing projects achieve their goals. And then finally, I am straying right out from science territory into game territory, curiously. And so we're getting to... Okay, this is, I think, the last project that I will cover on the stream. And now we're talking about Minecraft at home. Yes, Minecraft has a distributed computing project for some reason. This is not like the others. Yes, because while others are going to contribute to like really cool science things like helping the fight against COVID-19, and then discovering new stars. Minecraft at home. What does you do? What does you do? What are you doing? But nonetheless, they are part of some really fascinating and cool discoveries. If you haven't watched, like, have you ever heard of the pack.png project to find the seed of the most iconic image in Minecraft history, the texture pack, the texture pack icon? So let's go to the website for pack.png. Yeah, this icon right here, and they actually utilizes Boing to help so they can distribute the Minecraft seed finding throughout multiple computers. Yes, Minecraft distributed computing is real. And yeah, it's seed searching is kind of like brute forcing key in the in the encryption problem. So you basically have to brute force finding seeds, and that's why it's like a perfect use case to be distributed towards multiple computers. Other than the pack.png the pack.png search, I think they are also involved in the search for the seed for the world in the Minecraft splash screen. So okay, if you want to read more about the process for searching the pack.png or the splash screen seed in Minecraft, okay, so a YouTuber called Siauw, you might have heard them from 2B2T content, but yeah, a YouTuber called Siauw, they talk about the pack.png project. So that I recommend you to watch some of their videos. Okay, let me talk a bit about here. So yeah, they Siauw has let me switch to the browser here. Siauw have been covering the pack.png progress since quite some time. It kind of okay, it's kind of a long time they're searching for it. Yeah, 3 videos, but they talk a bit about those, and the seed has been found around September of 2020. Okay, I think I should be okay. I will post the link to this particular video playlist here. So please go to that playlist if you want to search deep into the search for pack.png. Click that link after the stream, of course. Yeah, some very interesting stuff. And then and those are like those are just some of the projects that are made with Boing. And you can always check out for more on the Boing website. You can discover more projects like those. Other honorable mentions that I'm going to mention here include projects like okay, let me let me search for. Okay, there are also some really cool projects like searching. Okay, asteroids at home. I think I have not mentioned them. I originally intended to mention them, but I have not. Asteroids at home. You try to model asteroids, and then there's LHE at home. Your data can improve the Large Hadron Collider. And then there are also things like Universe at Home. It's pretty cool stuff. So yeah, please check out the Boing website to see the list of projects that are currently hosted there. They are pretty cool. And after that, let's talk about what I actually run on my systems to help those efforts. Okay, so yeah, this is the things that I actually run and I tested. First of all, I currently run two projects here. The first is, I run the Boing client, and I participate in 3 projects: Rosetta at Home, Einstein at Home, and World Community Grid. And on my laptop, I run Folding at Home. From all those projects, Boing is the more stable one on my phone. It does not seem to generate that heavy of a hit. But Folding at Home, let's just say I have to monitor thermals much more carefully on my old laptop, because if I don't watch it carefully, it can just boop. It can suddenly shut down because of thermals. Pretty nice stuff there. And this happened again. I was actually intending to do that. Okay, let me actually find the screenshot folders here. And okay, my Explorer is not here, so God bless. Okay, that opened there, and that is kind of a good news. This is what Boing looks like. This is my old phone, by the way. And yes, if you don't have a powerful computer and your phone is more powerful than your computer, you can run Boing on your phone. So when you go use your I don't know, charge your phone at night and then you just leave it for a long time, remember to either set up smart charging or just plug it in all the time. You can run the Boing client to help process projects at your phone. And yeah, the ones that I'm currently running here, I screenshotted this one around 2 hours before the stream. I'm currently completing Rosetta, and yeah, I also participate in the mapping cancer marker from World Community Grid. And then what next? Let's talk about my profile. The one that I have been intended to cover about. I actually I just created this yesterday, but I have managed to earn around 1,800 credits. They also apparently have a generator, so a certificate generator, quite curiously. My current progress is smooth and I will continue contributing in the future. Yeah, this certifies that Damillora has participated in Rosetta at Home since 25 July 2021 and has contributed 1,796 cobblestones of computation. That's around 1.55 quadrillion floating point operations to Rosetta at Home. That's pretty cool. And then as for my folding at home setup, and yes, this is an actual screenshot from the client. Yeah, you can participate it to help simulate COVID-19 proteins. Let's go to the web client soon. I'm switching to my browser. Yeah, I'm using the client on my browser here. Okay, let me navigate to that laptop. Yeah, this is my folding at home dashboard. I'm currently setting up the power on at light because what happens if I increase it to medium or full, the GPU will get used and my computer will basically just get get too hot and it will shut down automatically. So I have to use the light power setting. And yeah, I have actually created a theme for folding at home. And you can see on the presentation here, if you want to join me, my team is folding at Moon Tempest. With Moon Tempest is I will explain later when I actually have built a website for it. But yeah, it's kind of it's kind of an umbrella for everything that I do under this VTuber banner. So yeah, that is Moon Tempest, and then yeah, if you want to join me, you can input the Moon Tempest team ID 10611944 when joining the folding at home. When setting up the folding at home client, please enter my team ID there, and we can help contribute research together. But I will of course give you some warning before actually diving into before you actually want to whoa, this sounds so cool, I want to try running it. But there are some factors that need to be addressed first. Yeah, first of all, computation is not free. They cost actual real energy. But in turn, you will be able to contribute to lots of cool things. As I said before, you can essentially be a frontliner in the fight against COVID. Isn't that cool? You're computing all those simulations so that the scientists can look at it and then see what can they do for COVID-19 treatments. That is really cool. But yeah, reminder that they cost real energy and it will also affect heat on your computer, so make sure your computer is equipped to do those computations. And also mind your hardware and occasionally monitor your computer to make sure it's not overheating or throttling, because too much heat is bad for the computer. It's kind of like it's kind of like mining, but what you do is actually beneficial to society, unlike cryptocurrency mining. And yeah, my laptop absolutely cannot handle the heat of folding at home with both CPU and GPU enabled. So I have to tone down my progress quite a bit and set it to light. Meanwhile, I don't have such a problem with Boing, so thankfully. Yeah. So let's see a little bit about those softwares. I will be going to download them. Cool stuff, cool stuff. Okay, let's go and first let's look on the Great Internet Merchant Prime Search. Let me switch to the window capture here. Yeah, this is games. This is such a such a really interesting website. Let's download Prime 95. Let's download the Windows 64-bit stuff. Okay, let's switch to the games window, Prime 95. Welcome to games, the hunt for huge prime numbers. You will be asked a few simple questions and then the program will contact the PrimeNet server to get some work for the computer. Good luck. Attention overclockers, Prime 95 has gained a reputation as a useful stress testing tool for the people that enjoy pushing their hardware to the limit. You are more than welcome to use this software for that purpose. Please select the stress testing button below to avoid interfering with the PrimeNet server. Use option /turtle test menu to menu choice for your stress test. Also, read the stress.txt file. If you want to bot join games and run stress tests, then click join games below and answer the questions. After the server gets some work for you, choose test stop, then options turtle test. I am not going to actually, go for the join games here because I'm not interested to run run for mathematical things. Let's do a turtle test. Run a turtle test here. Let's run that one and see just how much my computer slows down thanks to Prime 95. Beginning a continuous self-test on your computer. Let me open Task Manager here to see how heavy it is using my CPU. Wow, guys, I will switch to the Task Manager. You have to see this. Wow. Okay, so I have the Task Manager here and I have some applications running. You can look Windows Explorer, VTuber Studio, the tracking software that I use, Task Manager, Prime 95 itself, and then OBS Studio, and then PowerPoint, and some of my other stuff. Look at that CPU usage, guys. 100%. And 95 Prime 95 is taking around 50 to 60% of the CPU usage here. Yes, waka waka waka, CPU 100%. Yes, yeah, 100% CPU guys. Dan ini berkat Prime 95. Dan inilah yang akan terjadi kalau misalnya kalian itu sih, ini stress testing sih. Also, you might not be able to hear this, but the CPU fans are running loud, really loud. Kencang banget CPU fan-nya. Terus kemudian, as you can see here, the memory usage is, wow, 93%, amazing. But I am going to stop Prime 95. And wow, the amount of work that just goes winding down is amazing. Wow. I can hear the CPU fans winding down. High-end PC indeed. Ya, itu lumayan gila sih. I don't want to repeat that again. Gila banget. I'm going to switch back from here. I have demonstrated Boing and folding at home. And also you can see Prime 95 there ya. Ya, jadi karena emang games itu emang bener-bener intensif CPU sih. Makanya ya sering dipakai juga buat stress testing buat para overclocker. Ya terus buat folding at home aku nggak bakal nge-cover lebih dalam lagi karena aku udah basically tunjukin sih dia kayak gimana sih kalau di kliennya itu. Okay, I will need to switch to the display capture for a bit here. Yeah, it's kind of a miracle that I used the CPU really hard there and it still manages to hold just fine. That is this computer is pretty amazing. Dan ya seperti yang bisa dilihat di sini ya, I'm folding as Damillora and this is tim folding at Moon Tempest. Kalau misalnya kalian mau coba-coba join silakan kalian ke tim ya. Kalian kalau mau join tim aku silakan. Ini tim ID aku. And as you can see here, I'm running here and I'm contributing to project 17231. That's the coronavirus project. Coronavirus SARS-CoV-2 COVID-19 causing virus proteins. These are high priority projects to simulate the proteins of the COVID-19. Yes, ya. Jadi ini kalau dengan kalian bergabung di kayak folding at home gini, kalian bisa membantu untuk meriset COVID-19. Ya, kalau misalnya kalian kepengen ini pandemi ini tolong ini nih. Kalian pengen membantu orang yang kayak secara nggak langsung sih, tapi kalau kalian mau membantu progres terhadap penyembuhan itu terhadap pandemi COVID-19 ini, kalian bisa membantu dengan mendownload folding at home terus kalian jalanin itunya. But as always, be mindful of your hardware. Ya, buat Rosetta at home, ya Boing segala macem. Well, it's on my phone. It's kind of hard to display here. So I will not be displaying the Boing here. But so that's the topic for today. Ini topik yang kayak ini kalau pas aku keinget ini lagi kayak wow, ini menarik nih. Ini bisa, kalian bisa kontribusi waktu PC kalian. Kalau misalnya kalian lagi diemin PC kalian, dibanding dibikin ngegabut, kalian bantu buat, kalian bantu bantu pertarungan terhadap COVID-19. That's a cool thing. Tapi as always, ada masalah soal itu sih. Lifetime hardware-nya. Jadi itu sih. So at this point, if you have any questions about volunteer distributed computing, you may ask here on chat. So I will read it and then I will try to answer it to the best of my ability. Kalau misalnya kalian ada pertanyaan, kalian bisa tanyakan di chat, aku bakal coba jawab. Okay, I will just reading on the hardware requirements. Okay, yeah. So yeah. Hmm. Oh yeah. Yeah. I may have just realized it. But did Linus Tech Tips talk about folding at home? Oh, they did. They actually did cover, but yeah, I am absolutely not aware of Linus Tech Tips covering folding at home. But yeah. Oke ya, kalau misalnya udah gak ada pertanyaan lagi, if there are no more questions, yeah, I think that's the end of the stream. Kalau misalnya udah gak ada pertanyaan lagi, itu sih. Ya sekiranya udah kelar lah. And so ya, kalau kayak gitu ya aku bakal switching balik ke itu. Aku bakal switching balik. Announcement time. Oke. Okay. For the announcements, okay, as I previously posted, I have published the schedules for my streams. Ya, buat week 6, I will be having 4 streams. Jadi ya hari ini stream ini teknologi dev ke-6 volunteer distributed computing. Besok libur, lusa pop links, and then the next day I will be covering Azurland again. Is the dates right? I think the dates are not right here. Oh. Yeah. The timing is slightly off there. Yeah. The visual stream is actually will be on the 31st. I absolutely did not notice that. But yeah. Let me update. Okay. It does not seem to change for some reason. Oh. Oke, aku udah update. Aku udah update jadwal terbarunya di Twitter aku. So, I have updated the schedule on my Twitter, so please do check that. But yeah, jadi ya oke, schedule-nya udah diupdate. Jadi tanggal 31 ya buat stream visual 3, bukan tanggal 30. Ya. Ya stream ya ini sih. Jadi well, kayaknya itu sih ya permainannya kalau nggak yang bisa didiamin ya game puzzle santai. Ya so ya okay. So thank you everyone for watching this particular stream. And if you want to join in, if you want to join in those cool, really cool volunteer distributed computing projects, please check out their websites. Ya, searching aja di Google namanya, entah itu ya folding at home games atau ya project-project Boing, ya silakan kalian search aja. Banyak informasinya. And you can also research things like, computer longevity and stuff. Apa ini ngefek gak sih ke komputer kalau misalnya aku jalanin kayak folding at home terus menerus? Yeah, the amount of if you don't want to stretch your computer that much, I don't recommend you to run folding at home, but yeah. Yeah, actually the only thing that I think I'm willing to run for a long time is probably it's going to be probably the Boing on my phone. Ya, tapi ya itu sih. lihat dah itu laptop bisa tahan berapa lama folding at home, berapa lama bisa tahan rusak. Yeah, but so far that laptop has had only its hard drive replaced. Jadi kayaknya aman-aman aja sih. Ntar paling keburu beli laptop baru ini. Keburu beli laptop baru paling pas udah rusak. Yeah, I want a MacBook. But yeah, this computer is powerful enough, so yeah. Pengen coba Apple Silicon. Tapi ya nabung dulu. MacBooks are pretty cool, but they're pretty expensive. Okay, so that's it for the stream today. Thank you everyone for watching this stream where I talk about those cool computing projects. Yeah, if you like my content here, yeah, please subscribe to this channel. I think it recently received around 100 subscribers. So yeah, I want to thank everyone who has I want to thank everyone for following my content here. Yeah, I have reached around 100 subscribers. And yes, see you tomorrow. See you in 2 days, and have a nice day.